Hello, my lovely sixth graders. I have missed you. I decided to come on here and create this video because some of you have already had a few questions on these assignments. I love the fact that some of you have taken responsibility for your learning and you're getting straight into it. If you have not already started, that is totally okay. It is Sunday. I get it. On Monday, I would love to see a few more of you start to do this. So if we go ahead and look at 6.1 or 610D, lesson 1, it says, please click through the slides and review the activities for today's lesson. You will not be able to write on these slides, so you're going to have to be writing on a piece of paper. Some of you have decided to write them down on a Google Doc and send them to me, and that way I can make comments on it and direct you in which way you went wrong. And I have been doing some of that today. So if you would like to do that, you can. It is not necessary. You don't have to, but if you do have questions, that's probably one of the easiest ways to do it. But anyway, we're going to continue on. In this lesson, we are going to review plate tectonics. We're going to review the layers of the Earth. We're going to review that the Earth is broken into plates. These plates float on the atmosphere. I'm so sorry. These plates float on the asthenosphere. Convergent, divergent, and transform movements. Remember, we played Simon Says with that. And major geological events. On this slide, you are to click on it and watch the video. You're going to watch the video and answer these questions. What happens under the Earth to cause the volcanic eruption? On what layer of Earth can you find a volcano? How do you know? And how are volcanoes formed? So go ahead right now, pause this video, click on the watch this video, and you can go ahead and watch that on your own. Once you have finished that, go ahead and answer the questions.
It's a glimpse into the center of the Earth. It's like listening to the heartbeat of the planet. The physiological effects of being inside the volcano are significant in that you have every force down there trying to kill you.
All right, so let's use the drone to...
I wanted to share the Maram crater that's located in the island nation of Vanuatu by bringing a team with me and documenting this place in a way that's never been seen. The drone that we used is called the Phantom 2 Vision Plus. We had also GoPros mounted onto these particular drones with gimbaled devices so that no matter how much they shook, the video remained stable. We were able to take a series of thousands of photographs around the top of the crater and then process those using a specialized software to render the first of its kind 3D model of the volcano from inside. We were fortunate in that we got the footage we were looking for, and unfortunate in the fact that we lost our drones. They fell to their demise, some into the lava and others just from the incredible amount of heat and unstable air. You have sulfur dioxide and toxic gases that are superheated and just an incredible radiant heat that exceeds 1,000 degrees Fahrenheit standing right next to it.
Well, if you're looking for extreme locations, it doesn't get much better than an erupting volcano on Vanuatu. We were there to investigate how quickly microbial colonization happens on rocks. We certainly wouldn't imagine that there is life in the lava lake itself, just way too hot for anything to happen. But the instant the rock cools to below about 120 degrees Celsius, it's considered a habitable environment. Getting a handle on how microbes can colonize this particular substrate is a good example of what will happen across the planet and has happened across the planet throughout geologic time. Having the cameras everywhere, particularly during the sampling at the very edge of the lava lake, is critical because we can go back and see exactly how far we were from the edge, exactly how closely distributed these newly formed rocks were. This isn't something you can measure in the moment. 3D reconstruction of the crater itself will be very useful in figuring out which layers are iron rich, which layers are sulfur rich. Within the caldera as a whole, there's certainly life. Coating the walls as you go down, on some of the surfaces down at the bottom, almost certainly there's a high microbial constituency.
Why do you guys think that he was wearing one of those suits? They said it earlier in the video. So why do you guys think that he's wearing one of those suits? I think that it is very important for you guys to realize how hot it is, what type of chemicals are coming out of that area, and so forth. So just think about that. You don't have to answer me. Just keep that in mind.
The greatest scientific value is just having videographic support that can be used in tandem with other research that's happening in the world. I really believe there's an opportunity to merge those worlds of exploration and tech, and coming back and reporting on all kinds of information that has not yet been discovered.
So I went ahead and played the video. If you wanted to, you could have skipped through that if you had already watched it. That's fine. Again, so why do you think, or what happens under the earth to cause this volcanic eruption? On what layer of the earth? Can you find a volcano? How do you know? Think about in the video when they showed the reconstruction, the technology they used to recreate that volcano on the computer. Think about what layers of or layer of earth that this volcano is found. And how are volcanoes formed? Think about that, write it down. You can pause this video at any time to do that, and so forth. So moving on, we're going to look at activity 1, and this is the layers of the earth. Remember, from the outermost, which is the outside, to the innermost, which is the inside, we've got our crust, our mantle, our outer core, and then our inner core. Remember that our crust is the very thinnest layer. Okay, so up here we've got our crust. And then the rest of the earth is all of this stuff, okay? So we've got our crust. This is what we live on. And then underneath all of that is this huge planet filled with magma and other elements like molten iron. Remember how we said that the inner core is solid, the outer core is liquid. The mantle is a solid, but it acts like a liquid, so it's plastic and putty-like, and that contains part of our asthenosphere. Our asthenosphere is our middle part of our mantle and the inner mantle, okay? Now, the lithosphere is the crust and the upper mantle. What happens inside the mantle that makes our plates move? Remember, we talked about that. It's a type of circular movement. We have a specific name for that. So go ahead and try and think about what that specific name is. Questions. The what can be found in the crust, and the what can be found in the mantle. Volcanoes and other geological events can be found where? Remember, we live on this part, the crust. We live on this part. So volcanoes and other geological events can be found where? Moving on to activity 2, Earth's plates. Okay, so remember that the earth is broken up into tiny plates. Now, I don't know why I said tiny. They're huge. They're huge plates. Just completely ignore what I just said. The Earth is broken up into huge plates, okay? They're like giant puzzle pieces that fit together, and they're moving. Tectonic plates are pieces of Earth's crust and uppermost mantle. Remember, the lithosphere is Earth's crust and the upper mantle. These plates can be oceanic or continental. Oceanic are the ones that have the major oceans on them. Right here is an oceanic plate. Over here is a continental plate. Pay attention to these dark lines. These dark lines are what we call plate boundaries. Plate boundaries are where the plates meet, where the puzzle pieces fit together. Something else to notice on this map are the arrows. When we see arrows, we always think about direction, don't we? So that's what these arrows are showing. They're showing us the direction of which the plate is moving. For example, this Nazca plate is moving towards the South American plate. If you look here, the South American plate is moving also towards the Nazca plate. The South American plate is moving away from the African plate. If you think about the plate boundaries that we have talked about, convergent, divergent, transform, what type of boundary is this one right here, where they're moving away from each other? Remember the sayings that we came up with. Convergent, collide, where they collide together. Divergent, divide, where they separate from each other. And transform, slide, where they move past each other. In this picture, it's hard to tell where any transform plates are. But if you pay close attention to this arrow, it shows us that this plate is moving this way. And then if you pay close attention to this arrow, it shows that this plate is also moving this way, which means that when two of them move towards or away from the same direction, where it's going this way and this way, they're sliding next to each other. Right here, we have something very famous called the San Andreas Fault. Many of you will recognize that word, that name, the San Andreas Fault. It's over here in California. The fault line is something that happens at transform boundaries, where they slide past each other. Look at the plates on slide 7, the slide we were just on. In what directions can you find the plates moving? This is something that you can think about or write down, but also that is just to think about how they're moving, if they're moving towards each other, away from each other, sliding against each other, and also keep in mind the names of the plate boundaries that we have talked about. Activity 3, plates on the asthenosphere. Tectonic plates are located on the lithosphere, or the crust, and they float on top of the asthenosphere, or the upper mantle. Okay, so here we have our lithosphere, and here we have our mantle. These plates float on top of this mantle. Remember how I said that the mantle is solid, but it acts like a liquid. It is solid, but it acts like a putty or a plastic where they can float on top of it. These plates are broken into pieces and are constantly moving. I'm going to click on this video for you to watch. If you would like to watch it on your own, that is fine. You can pause the video and fast forward a little bit. but I'm going to click on this video and we're going to watch this one very quickly.
This is planet Earth. The surface of Earth may look like it's all in one piece, but it's not. It's actually made up of several pieces called plates. Let me explain. Okay, so if you cut the Earth in half, this is what it would look like. The Earth is made up of 4 main layers, like a big round cake. The inner layer is called the inner core, which is a hard ball of hot metals. Around the inner core, there's the outer core, which is made up of very hot liquid metals. Then there's the mantle, which is made up of really hot melted rock, called magma. Sometimes, magma will come to the surface as lava in volcanoes. The 4th layer is called the crust. Like the crust of a piece of toast, the crust of the Earth is the hardest and outermost layer of the Earth. We live on the crust. The crust is not a perfect ball. It is broken up into many pieces called plates. These plates fit together like puzzle pieces around the Earth. Now, if you look at the map, you can see where the plate boundaries are. These plates are called tectonic plates, and these tectonic plates can move. This is the world today, and this is what scientists think the world looked like 300 million years ago. This landmass is called Pangaea.
Remember, we talked about Pangaea, how it was called a supercontinent. In our notes, we drew our supercontinent, our super Pangaea man.
And over time, the plates moved slowly apart. They moved at about the speed that your fingernails grow. So
if you look at Pangaea, they used to all fit together. Now, as the plates have moved apart, you will notice that they still have the same type of shape, with South America and Africa being one of our major indications. That is why we call them giant puzzle pieces.
It took a very long time for them to get to their present position. Remember the mantle from earlier? Well, the mantle is the layer of Earth right below the crust, and it is made of hot melted rock. This melted rock moves around the mantle, and since it's right below the crust, when the mantle moves, the tectonic plates of the crust move as well. The plates move in 3 ways. They converge, that means come together. When this happens, one plate subducts or goes under another plate, and it melts back into the mantle. This happens very slowly. Again, about as slow as your fingernails grow. And it happens mostly in oceans, so you don't have to worry about any land getting subducted anytime soon. When 2 continental or land plates come together, they form mountains. This is how the Himalayan mountain range was formed in India, the tallest mountain in the world. It formed when 2 plates crashed together and crumpled up, sort of like how a car crumples when it hits something big. The second way that plates interact is at divergent boundaries. This is where plates diverge or move apart. And this is also how oceans form.
Remember, we called that divergent divide, where they divide apart from each other. Also, this is how oceans are formed. Please pay attention to this.
As Pangaea began to break up and the Americas began to move farther away from Africa, the Atlantic Ocean formed in between the continents as the plates diverged. In the middle of the Atlantic Ocean, you can see the Mid-Atlantic Ridge. This is where
the Mid-Atlantic Ridge, if you look on a topographic map, you can see starts all the way up here and goes all the way down. There's a huge crack in the earth right here, all the way up and down. That is where the plates are moving away from each other. If you look, you can see these underwater mountain ranges formed.
North American and Eurasian plates meet, and this is where they are being moved apart. Here, new ocean crust is formed, which pushes the Americas and Europe about 1 inch far.
In some parts near the Northern American and European plates, or the Eurasian plate, you can stand in between the two or swim in between the two and touch the North American plate and the Eurasian plate.
Farther apart every year. The third way that plates can interact is at transform faults. A transform boundary is when 2 plates are not moving together or converging, and they're not moving apart or diverging. Instead, these plates simply slide next to each other. This is happening in California right now, along the San Andreas fault line. This is why there are so many earthquakes in California. When the two plates rub together, they shake the ground and make earthquakes. Okay, so let's review. The Earth is made up of layers, and the top layer is the crust. The crust is broken down into tectonic plates, which very slowly move around the Earth because of movement in the mantle, which is the hot layer of melted rock under the crust. The plates move together at convergent boundaries, they move apart at divergent boundaries, and they slide past each other at transform boundaries. The movement of the plates is extremely slow, and there is very little change every year. But over millions and billions of years, you can see big changes in the way the Earth looks. We know all of this because of great scientists who dedicated their lives to researching and trying to learn more about this great planet we call home.
Activity 4, Convergent, Divergent, and Transform. This video can teach you a song to differentiate between the 3 types of plate boundaries. If any of you would like to send in a video of you doing this song or singing this song, you may do so, and I can post it to Twitter or the YouTube channel if you give me permission.
Hey everybody, this is Mr. Comerford. Welcome to the Plate Boundary Rap, which will teach you about the 3 types of tectonic plate boundaries, as well as the formations and events you would expect to find at each. Let's do this thing. Nails grow and as Wegener helped discover boundaries that converge, come together, diverge, pull apart, transform, slide past each other. Converge, collide, diverge, divide, transform, tectonic plate slide. Converge, collide, diverge, divide, transform, tectonic plate slide. When plates converge, one or two things happen, so listen up and I'll continue rapping. They push each other up, making mountains the norm, or subduction occurs and then volcanoes form. Converge, collide, diverge, divide, transform, tectonic plate slide. Converge, collide, diverge, divide, transform, tectonic plate slide. When plates diverge, crust splits apart, so it causes magma to rise from the mantle below. And depending if it happens on land or at sea, this process forms mid-ocean ridges or rift valley. Converge, collide, diverge, divide, transform, tectonic plate slide. Converge, collide, diverge, divide, transform, tectonic plate slide. When plates transform, they slide and grind. So with this type of boundary, you probably find in this process ain't smooth. The plates are jerking and breaking, and sudden release cause a violent earthquake. Converge, collide, diverge, divide, transform, tectonic plate slide. Converge, collide, diverge, divide, transform, tectonic plate slide. Plates move slow as your fingernails grow, and as Wegener helped discover, boundaries that converge, come together, diverge, pull apart, transform, slide past each other. Alright people, that is all for now, but please remember convergent plate boundaries, divergent plate boundaries, transform plate boundaries, and all the events and features you would expect to find at each one. I'll see you next time.
Again, that may have been a little hard to hear, so if you wanted to click on it on your own, go ahead and do so. Activity 4 questions. Describe the type of motion in a convergent boundary. Describe the type of motion in a divergent boundary. And describe the type of motion in a transform boundary. All of that was just said in that video above, and we've gone through it in class. Remember our hand motions that we did. So if you would like to, go ahead, take your hands, make them into fists, and push them closer together. When they come together, you have your convergent boundary. Remember, convergent, collide. Now take your hands and move them away from each other. That is your divergent divide boundary. Now put your hands together and make the clapping noise as they slide past each other. That is your transform boundary. Your transform slide. Major geological events. Some key information. Movement along the plates causes destructive and constructive forces. What does destructive mean? What does constructive mean? Destructive is when things are destroyed, and constructive is when things are created, like new ocean crust or new mountains. Destructive, when things are destroyed, like with a subduction zone, when one of the when one of the plates goes below the other, and then that crust melts underneath the other plate. Remember, after that, something can form by that magma then being hot and it rising and creating volcanoes. Geologic events and landforms are used to locate and classify plate boundaries, as well as measure the rate of plate movement. What this means is when we look at mountains and we can tell how old they are, we can tell that these plates were moving together faster than in other places. Divergent plate boundaries create new land. So when they move apart, they create that new magma coming up and creating new land, like at our mid-ocean ridge. The next slide is going to be a review of geological events that occur at each boundary. At divergent plates, ocean basins can be created. Whenever Pangea started to move apart, that's how we got our Atlantic Ocean. Also, mid-ocean ridges are created. That was that big crack all the way down the earth where new ocean crust is being formed. In our convergent plates, mountains and volcanoes are created. In our transform plates, earthquakes are created. When these plates slide past each other, that is when an earthquake happens at these fault lines. Again, when I was talking about on a convergent plate, when one plate goes beneath the other, this crust gets melted, and then it heats up and rises, and that's where all our volcanoes can occur. In this activity, you will review the slide deck and decide which picture does not belong. Please provide an explanation. Here you see 4 different objects, A, B, C, and D. A is a picture of mountains, B says convergent boundary, C is 2 convergent plates coming together, and D says divergent boundary. Which one does not belong here? Which one is different from all of the others? Think about it and create an explanation as to why that one would be the odd one out. Here we've got more. In A, we have water in between 2 plates with magma right below it. Which one would that be? B, we have 2 plates diverging from each other. C, we have 2 plates coming together. And D, it says divergent boundary. Which one's different from all of the other ones? For the rest of this slide deck, you're going to go through and decide which one is different from the rest of them. You'll do that on your own. If you would like to send it to me through a Google Doc, you may do so. Down here, they have different options. There are more than 4. Notice A, B, C, D, and E. You'll tell me which one's the odd one out. Which one is different from the others? You come up with your explanation, and if you justify your explanation, I'll be able to tell you if you're right or wrong. The best way to do it, if you send it to me in a Google Doc, is you look over here where it says the slide number. Notice this one right here is slide 12. So you'll write slide 12, and you'll tell me which one is the odd one out and why. While you're doing this, please try and practice using your complete sentences. Please try and practice using your grammar as well. All right, so that's it for this presentation. I know it was quite long, but if you have any questions, don't be afraid to reach out and ask me. I hope this helped answer some of your questions and helped you figure it out a little bit easier as to just doing it on your own. If you would like me to continue doing this with lesson 2, please let me know. One thing that I suggest is to subscribe to the YouTube channel just so that you can get notifications on when I post a new video. That way that you can stay up to date and stay on task. Again, if you have any questions, don't be afraid to ask me. All right. See you guys next time.